I want to start from this function. Question 1. Let Z1 be equal to 2i. And then express the root of Z1 in the form a plus bi. Okay, so since we are going to express the root of zi in the form a plus bi, now if you look at z1, z1 is equal to 2i. Okay. So someone is asking if they're the only one who cannot get me. I don't know. Are you getting me again?
Yes, we are.
So we have, so the best way is, since we want to express this number, that complex number, as a plus bi. So we better say, okay, let a plus bi be equal to the number that we have here, the root of z1. Meaning a plus bi is equal to the root of 2i. Now, we need to extract that root from there. We need to express the root of 2i as a plus bi. So what we do is we square this side. We also square this side. So that we have a plus bi multiplied by a plus bi equal to 2i. Like that. So we do the expansion. So we have a times a is a squared plus abi plus abi minus b squared equal to 2i. So minus b squared, because I times I is equal to -1. So don't forget, I squared is equal to -1. Then we come back here and say, okay, we want to put the like terms together. So a squared minus b squared plus 2abi is equal to 2i. Now I want to mention this here, that two complex numbers, a plus bi, will only be equal. So a plus bi and x plus iy, these two will only be equal if a is equal to x and b is equal to y. So the real parts must be equal to each other, and the complex, which are the imaginary parts, should also be equal to each other. So from that, what we learn here is that the real part this side is actually 0. Okay, so we're going to equate a squared minus b squared to 0 and 2ab to 2. So we have two equations that must be solved now simultaneously for us to get the values of a and b. Our target here is to find a and b. So we can divide by 2 here, divide by 2 there, and get ab equal to 1. Like that. We can come back here and say, okay, what happens if you solve for one of them here? Let's solve for b. B is going to be 1 over a. So that we substitute it in here. So now we're now using substitution method. So we have a squared minus 1 over a. What is b? But this must be squared equal to 0. So that we get a squared minus 1 over a squared equal to 0. Multiply throughout by a squared. So we're going to have a4 minus 1 is equal to 0. So this will imply that a4 is actually equal to 1. So if something is to the even power and it's giving you 1, then you know that we could have had a plus or minus 1. Because any of those two, if you raise to the power 4, it will give you a positive 1. Like that. So we have now found the value of a. Now let's go back where we left b. We said b is equal to 1 over a. So if a is equal to 1, then b will be 1 over 1, which is equal to 1. If a is equal to negative 1, then b will be 1 over negative 1, which is equal to negative 1. So what does it mean? It means that we have two options for a plus bi. That is 1 plus 1i, or a plus bi is equal to minus 1 minus I. So we have those two options. We have those two options. Okay. How is it?
Sir,
Yes.
how do you present your final answer? Like, do you write it in the way you have written it last? Is that how you present your final answer? Or you simply say A is equals to positive 1 and negative 1, B is also equals to positive 1 and negative 1, or you write it the way you've written it?
You're right, they have written it.
All right, sir. Thank you.
Okay. This one we are clear. Remember that time it was left hanging, so now you look like you are quiet. So that's okay. When you are quiet, I know what you
Excuse
mean.
me,
You're
sir.
crying. Yes.
She asked about how you present your answer, and I didn't get what she said.
Like this.
Okay, thank you.
Yeah.
Sir,
Hello.
yeah. I'm confused whether how come the other one is positive and the other one is negative I?
How the other one is positive, the other one is negative. Because look, B depends on A. So when A is negative, B also is negative. And why are we saying plus or minus? Because this is an even power. It's like squared. So you'd say A squared is equal to 1, meaning A is equal to plus or minus 1. Okay? Let's go to the next one.
Excuse me, sir, just before you go to the next one, I have a quick question. Yeah, I'm a little bit behind on, I was kindly asking if you can maybe repeat that same screen. That's when I can clearly see and show you the question I have. Yeah, thank you. I'm a little bit behind. Just run me through on the part where it's a squared minus 1 over a in bracket squared is equal to 0. From there, my network was somehow bad. So I was just kindly asking if you can just run me through how you go to the final answer from there.
So from here,
Yes.
when we square this A to be A squared, then we multiply throughout by A squared. So we have A4 minus 1 equal to 0. You see that?
0, yes.
Then,
Yes, I see.
when this one goes the other side, to be positive.
Yes.
Now, the power being even, it means that we have plus or minus 1. That can give us 1 left.
Sure.
And so, we get these two and go back to B. This B is 1 over A. So when A is positive 1, B is going to be positive 1 also. When A is negative 1, B is going to be negative 1 also. So we have A plus BI equal to 1 plus I, and A plus BI equal to negative 1 minus I, because the I is being multiplied by the 1.
All right, thank you.
Okay. So now we move. So we have given that 5 plus the root of 2 is irrational. Okay. If this is irrational, oh, okay, so wait. We want to show, so the question should read like this. Prove that five plus root 2 is irrational, and given that root 2 is irrational. So we are told that root 2 is irrational. If the power was not even, you'd have gotten only one number. 1. That's the follow-up question on the previous one. So now, your job here, and they will tell you that root 2 is irrational. Whatever number they will put there, they will tell you that it is irrational. And then they'll bring it here. and ask you to prove that that whole thing is rational. The job is not even that much. You just say, okay, you want me to prove? I'll do it. I'll let 5 plus root 2 be equal to A over B. Then give conditions to B. B not 0. A, B, real numbers. Should they be real? No. A, B, integers. And then A, B, they do not have any common factor. Let me put it here. Okay, so we want it not to have any common factor, yeah, those two, because that's where actually the argument is. If you leave out that part, you have nothing to prove. That's what happens when you. So after that, that statement is almost everything. It's finishing the discussion. Because now the job we have is to come back here and make root to the subject. So we take 5 this side. And just one more step, we put B down. So we have A minus 5B. That is if we put a 1 there. So just putting those two fractions together. Is that a question?
Yes, sir.
Uh-huh.
So this means that this statement here, you give marks like to just for writing this statement, or what? Let's say you get the final answer to be wrong as you solve it going down.
So what happens is this. I'll show you how we mark it when we're done.
Okay.
So here now you write, since the left-hand side is irrational, and the right-hand side is rational. There's a contradiction here. Hence, 5 plus root 2 is irrational. Like that. Yeah, saying co-prime and not a common factor is the same thing. So when marking, so you have 2 marks, 1 mark, 1 mark.
That's what a statement.
So what's what that? Because that's the key state. That statement
So what
is.
if that gives you a question?
Uh-huh.
What if that give you a question where both 5 and 2 have roots? Like they both have the square root.
They will tell you that one of them is irrational. So there's this question which is nice here. Let me just get it.
So, sir,
Okay, so it's this question. It says, given that √2 is irrational, so that the fourth root of that over √3 is irrational. So they've told us that √2 is irrational. And they've given us two things, a √3 not mentioned, and they mentioned √2. So we start by writing the statement. Let the fourth root of that over √3 equal to a over b, such that b is non-zero. Okay. A, b are integers, and a, b are co-prime. So saying co-prime and saying that they don't have a common factor, it's the same thing. Then now, after this statement, 2 marks. They're looking for 2 more. So you come here and cross multiply. So you write this as the fourth root of 2 equal to √3a over b. And then if you square, you start by squaring. You are going to have from the fourth root, you now have the square root. Because 2 has gone, is equal to 3a squared over b squared. So, but we are told that √2 is irrational here. So you say, which is a contradiction. Since the left-hand side is irrational. And the right-hand side is irrational. Hence, the fourth root of this guy over this is irrational. That's how you show.
I don't know, I don't understand. Yeah.
Are you recording me?
It's recording.
So what's the confusion? Where is the issue? After the statement, then you make √2 the subject of the formula. That's all you are doing. The fourth root is like this, 2 to the power 1 over 4. So if I square this, I'm saying 2 to the power 2 over 4, which is 2 to the power half. Then 2 to the power half is the root 2. So now listen, this question, whatever they will mention here, as being irrational, whatever they will mention here as being irrational, that is what you solve to make the subject of the formula. So you will solve it until it's a subject of the formula. Once you've managed to leave it alone, then you are done. Conclude, because whatever you are going to have on the right will be rational. And on the left, you are told it's irrational. That's where they separate. So you say, oh, okay, my left hand side is irrational. My right is rational. Hence a contradiction. And so this guy is irrational.
Mr. Keith, I have a question.
Mhm.
In the question where we have root 2, for example, we have 3 root 2. How would you solve it? Because if you square it, the 2 will go, the 3 will be squared. Then we will not have any irrational number.
If you have the 3 root 2, you just divide by 3 and leave root 2 alone.
Okay, thanks.
Question 4. Rationalize. One. X minus 2y over root x plus root y minus 1. This was in the exam. We don't have an exam paper.
Sir, before you proceed, I have a question.
Mhm.
Let's say you have root 3 plus root 2, and then they say root 3 is irrational. Then how are you supposed to deal with the root 2? Are you supposed to take it to the other side, or how can you solve it?
You take the one that they have mentioned to be rational. You take it the other side and then square. Because if you leave it, if we leave it and take the non-mentioned, when we square, the one they have mentioned will disappear. So we'll be in trouble. So if they say root 3 is irrational, you leave root 2 and take root 3. Because you know when you square, the root 3 will remain. Okay, so you're going to have 2 is equal to a squared over b squared minus 2 root 3 a over b plus 3. So the job would now be to make root 3 the subject. Once you manage to do that, then you're done.
Okay. Before you do us this, let me just screenshot. Okay, sir, thank you.
So we have our saying rationalize. X minus 2y over root x plus root y minus 1. So here to rationalize, of course, I'm talking about the denominator. So you multiply by root x plus root y plus 1. And also up here, by root x plus root y plus 1. So change the sign of 1. And so we can expand. So we have
Sir, I have a question. When you're changing the signs, do you change the signs of the one that has a root, or just anything that's anywhere where there's a sign?
For now, you change the sign of one of them.
Oh, okay. Thank you.
So now we have this.
So it doesn't matter which one you choose.
Doesn't.
All right.
So we have x plus x root y plus root x root y. Here we are doing this by that, this by that, and then we do again plus root x. Then we come back and multiply by root y. So plus root x root y, and then plus y, and then plus root y, and then minus root x, and then minus root y, and then minus 1. So you see that this part and this part will go, this one and that one will go. So we have x minus 2y root x plus root y plus 1 over x plus y minus 1 plus 2 root x root y. So you treat this as one thing, and this also as one thing. So now this, even before I finish writing, it will cut. So I won't try it. I'll trust you to finish it. So you multiply again this. By that time, change this sign here to minus. And leave one down. Don't expand up. It's not important. So 10 minutes later, we join again.